Hello everyone. Today we are going to discuss about the intensity of electric field is directly proportional to the density of the electric field lines, and in other words we can say that we are proving that electric field is more near the charge, and we will show here how this happens. So this also gives us an idea, as I've stated before also, that the density of electric field lines is directly proportional to the electric field intensity at that point, right? So we'll first draw a diagram. Suppose we have a charge here. So this is the charge. We know that at every point around this charge, if this is your charge, so at every point around this charge, we have electric field lines coming out of it. These are imaginary lines, so we will mark these as lines emerging out. That means arrow will be outside, right? So if I want to show a particular part of the field lines on one side only, which I'll show why, then I'll draw it like this. For what am I doing actually is, you know the concept of the plane angle. Plane angle can be drawn on a plane. So this is the concept of plane angle which can be drawn on the plane. And the concept of solid angle, which you have studied in 11th standard, is like this. You have seen a birthday cap. So for a birthday cap, if you have a cone, right? So if you have a cone, then the angle here, which it makes with the vertex of the cone, this angle is called as solid angle. So what am I drawing is, we know that for every charge there will be a spherical symmetry. So the electric field lines will be drawn everywhere around it in 3 dimensions. So I am taking a particular part, conical part, from where the electric field lines are shown in this diagram, right? And this will be the solid angle which is made at the vertex of the cone here, right? So I hope this is clear. Now we can proceed to understand that how I have drawn this diagram. So from that cone, I am showing electric field lines which are emerging outwards from this cone. Right? And this cone will have the same solid angle everywhere, wherever we considered, whether closer to the vertex or away from the vertex. Even if we consider the solid angle here in this part of the cone, this will be same, or here in this part of the cone it will be same, because the same cone is making the same solid angle at the vertex of the cone, right? So that means this solid angle which the cone makes is, suppose, delta omega. We denote this solid angle by omega. This is called as omega. This is also called as omega. Omega you have used in angular velocity concept also, but this is also called as omega. This is solid angle, right? Now we are defining electric field in one more form which you haven't studied till now. We know that electric field is directly proportional to 1 upon r square, or you can say inversely proportional to the square of the separation. So more is the distance, less is the electric field. So we can also say that electric field is, intensity is number of field lines crossing per unit area normally through a region. So this way, if I consider an area which is closer to this charge and an area which is away from this charge like this, right? So I consider this point as P1, this point as P2, and I'm considering that the distance of this point P1 is R1, the distance of point P2 is R2. I mark the area here as A1 and this area as A2. And I consider a small surface area which is equal at two different places. So I am considering the same area here. So if this area is A, this area is A, right? You can see that from this, these are same areas, and from this the number of lines is more, and from this the number of lines is less. What we are trying to do is we are trying to find a relation between the electric field and area, and hence the distance. Distance we already know that there is a variation. So if we use this definition of electric field intensity as number of field lines per unit area crossing normally, right? So therefore we can write that electric field at this position and electric field at this position, we can write E1 is equal to number of field lines upon A1 and E2 is equal to number of field lines per unit area A2, right? We also know a formula which relates solid angle with the area. We know that for plane angle, theta is equal to arc upon radius. But solid angle, this is omega, is equal to area upon radius square. So if I want to write the area, from 1, area is equal to solid angle multiplied by distance square, right? So therefore I can write A1 is equal to delta omega, that is solid angle, into R1 square, because for this area this is the radius. Similarly, A2 is equal to delta omega into R2 square, right? I hope this is clear. Now from here, from 3 into right, we can write E1 is equal to n upon delta omega r1 square and E2 is equal to n upon delta omega r2 square. I can mark this as 4 and this as 5, right? So 4 divided by 5, we can write E1 upon E2 is equal to, this is number density, so number per unit area, that's why I have written n same over here. So this is n upon delta omega r1 square upon n upon delta omega r2 square, because this is the same solid angle for these two areas, right? And this will be cancelled, this will be cancelled. So this gives me r2 square upon r1 square, and this is actually the number of field lines crossing per unit area. This is electric field, so this way this is directly proportional to 1 upon r square. This also proves that density of field lines is directly proportional to the electric field. What does that mean? We all understand this, that more closer the field lines, more is the intensity of electric field. Therefore, closer field lines, more is the intensity of electric field, and further and vice versa. Right? So I hope this is clear. Now moreover, why the same number of lines pass through both the areas? The same number of lines pass through both the areas, we can count on over here also, because that electric field is proportional to 1 upon r square, and we can see that area is proportional to r square. This is from 1. Therefore, same number of lines pass through A1 and A2. So this was all about this proof that electric field intensity is more near the charge. That means E1 is greater than E2, because here the lines are closer. So this is all about the present video. That's all for now. Have a nice day.